A simple demonstration about projectile motion, particularly when a projectile is thrown horizontally.
Now this is Francis, quite a good-looking young lad. He has a ball, and this ball he is going to throw outside the door horizontally. So let's say the ball was thrown horizontally outside the door and has a velocity of 15 meters per second estimate. And let's say that the ball was thrown 2 meters above ground level.
So right now, based on the demonstration made, now we have two questions. And what are those questions? Letter A, how long did the ball travel before it hit the ground? And letter B, how far did the ball travel before it hit the ground? And now, I'm going to show you how to solve this problem.
So, in projectile motion, specifically when a projectile is thrown horizontally, there are given equations for you to help solve this problem. So, the problem is time, and there is a given equation for time. So, time is equal to the square root of 2 vertical distance over gravity. That is the given equation or formula for time. And now, we just need to substitute the values. So, time is equal to the square root of 2 multiplied by the vertical distance, which is 2 meters, over gravity, which is 9.8 meters per second. And now, we input this in our calculator, which is the square root of 2 multiplied by 2 meters over gravity, which is equivalent to 9.8 meters per second to get time. So, it is equal to 0.64 seconds. So, our time is t would be equal to 0.64 seconds. So it takes 0.64 seconds for the ball to travel before it hits the ground. So for letter B, the ball is traveling at a horizontal distance, so we need to find the horizontal distance for it. And the formula for horizontal distance is the horizontal distance, which is dx, should be equal to the velocity times the time, or multiplied by the time. And now it is stated that the horizontal distance would be equal to the velocity, in which case the horizontal component of the velocity is constant, so it would be the given velocity, 15 meters per second, which is multiplied by the time, 0.64 seconds. And now, we have only to input this in our calculator. 15 times 0.64 seconds would be equal to 9.6. So, the distance traveled by the ball was equal to 9.6 meters. So all in all, to answer our letter A, which is time, the ball traveled 0.64 seconds before it hit the ground. And to answer our letter B, which is distance, the ball traveled 9.6 meters before it hit the ground. So these are the solution and the answers to our very own problem.